Hello friends, good morning. Today I would like to talk about the motor, electrical motor. In every industry, whatever, oil and gas, fertilizers, power, wherever you have, even you can say pharma. In every industry you cannot have any equipment without motor. So most of the equipments are run by the electrical motor. Electrical motor may be of HT motor or LT motors, and that's why it is known as a driving machine. And most of the equipments like fans, compressors, blowers, pumps, agitators, extruders, you name it, gearboxes, could not be run without the use of the electrical motor. So electrical motors may be HT and LT, maybe from you can say few HP, 5 HP, 6 HP, 1 HP to you can say 300 HP, 400 HP, 1 megawatt and up to 5 megawatt. Actually I have seen also this motor is driving the reciprocating compressor. Another feature of the motor is that generally it is run on 3000 RPM. 3000 RPM, why? Because in our India the electrical supply is on 50 Hertz. When you convert the 50 Hertz in the RPM, rotation per minute, it is 3000 RPM. Although heavy machines may be having, you can say 1000 RPM, 1500 RPM, 800 RPM. And how the RPM you can calculate depending upon the poles of the motor. So generally electrical motors, 50 Hertz motors, 3000 RPM motors are having the 2 poles. As you increase the pole, the speed of the motor gets decreases proportionally accordingly. Suppose if you have a 4 pole motors, then it may be the maximum RPM may be 1500. So in this way, depending upon the requirement, depending upon the machines, load and other things, you choose the motors mostly with with RPM and the power it can give to the driving machine. So another thing I would like to tell you about the motor, electrical motor particularly, these are the most simple machines. Why simple machines? They have only one rotor, which is known as a, you can say, electrical rotor, and one stator and some windings. Plus in the construction you will have a bearings as elements and some sealing elements. So in a sense it is a very simple, but the erection of this with other equipment like a pump, compressor and everything on the same base frame, these are the important things if you want to run electrical motor smoothly. Actually the electrical motor is a combination of principles of electricity as well as you can say principles of mechanical engineering. So mechanical engineering and electrical engineering both combined, then we have a creation of the electrical motor. So electrical motor is a function of the electricity and the mechanical components. When I talk about the problems in the electrical motor, then you will have 2 types of problems. One is related to the electrical and one is related to the mechanical. But symptoms may confuse you whether it is an electrical problem or mechanical problem. When you pass through any equipment, running equipment, you will have some sounds. And if you are experienced person, if you are having the habit to roam about around the equipments, you can distinguish simply the sounds from which equipment it is coming and why the sounds are coming. So what we call it is a LLF, look, listen and feel. This is very important for the operators, engineers and the maintenance engineers to see that we have a different sounds of electrical motor for running for different type equipments. So the person who is experienced and intelligent, he can distinguish whether this sound is coming from the motor and it is a electrical problem or it is coming from the bearings. Bearings, generally in the motors you are using the anti-friction bearings, and for the lubrication purpose you are using the greasing. So most of the greasing is done for the LT motors. HT motors, in some cases where the HT motors having the high speed as well as you can say they are very big, we generally using a general bearings. In general bearings, obviously we are using the lubrication oil. Otherwise most of the equipments, motors, electrical motors, we generally are using the anti-friction bearings, what you call ball bearings and spherical bearing and roller bearings, electrical bearings. And in this motor you will have a two type of bearings. One is a ND side, it is a locating bearing, and the driving side is a floating bearing. So in this motor, the bearings as well as the coupling for the rotor side, all these rotors should be in a balanced one. When you erect any electrical motor with any equipment, you have to have a proper alignment. If the alignment is not proper, most of the casualty is the electrical motor. Or if you have a not good base frame, then a base plate not smooth, not in a even, or you can say, then you will have some problems in the motor. Motor generally having the mechanical problems related to the bearings. They may not be fitting in a proper way in the end covers. You have end covers in the electrical motor. So there you have to have a, you can say, proper tolerances whenever bearings are fitted in the end covers. Generally end covers get damaged, and the bearing is getting rotated in the housing itself. So that is another problem. So you have to rectify the end cover. You cannot throw away straight away the motors whenever there is a problem of electrical motor. So there may be the problems related to the balancing of the rotor, there may be problem related to the bearing, there may be problem related to the end covers. So most of the cases we generally take this motor to the central workshop and see whether the rotor is okay, stator is okay, end cover is okay. When everything is okay, you have to have a proper tolerances from the bearing, and where the bearing is fitted, I mean the portion of the rotor, electrical motor where the bearing is fitted, that should be smooth and having no problem related to it. Sometimes what happens in the running conditions, because of the rotation of the bearings or bearing damage, we also get damaged the rotor. So then you have to rectify the rotor also. Sometimes because of the loads, uneven loads or sudden stoppage or heavy loads, this rotor gets bending also. So there is another problem mostly coming in the bending of the rotor of the electrical motors. Now how you want to monitor the motor? Generally motor should be monitored by, I said ki, the strategy of LLF, look, listen and feel. There you will find many type of problems related to the greasing. You have to grease in a proper quantity and with the regular interval. Every interval is given to for the every motor, how much bearing should be used and when it should be replaced. There is a provision when you are topping up the greasing and you are taking out the old used greasing from the bearing. So monitoring as a LLF, it is a good indicator. Then you have to have a schedule for the vibration measurement. Depending upon the criticality of the equipment, you can measure every month, you can measure every 15 days. The vibration generally should be in the range of the acceptable range, and 2 or 3 mm per second. When you are having any problem the equipment, sometimes you doubt that whether this problem is related to the motor or related to the driven equipment. Driven equipment means pumps, compressors, or gearboxes or fans, blowers, whatever. So what you do, you decouple it, and also sometimes you take the vibration in the decoupled condition. But when you are taking the vibration in decoupled, only few problems you can identify whether it is coming from the electrical motor or not. So when the vibration is very low, it doesn't mean the motor or base frame is first class, is okay, but at least you can isolate. Why I am saying? Because the health of the electrical motor can only be identified when it is loaded with the equipment, where it is coupled with the equipment. So you have to take the vibration in the decoupled conditions just for a reference, and then you also take the vibration in the coupled condition. This way you can identify and isolate whether it is a electrical problem or mechanical problem. To identify the mechanical and electrical problem, there is a specific technique which is known as a MCS, means motor current signature analysis. By this also method you can isolate whether it is a problem related to the electrical, it is a beads, or some winding is loose, or problem in the rotor, or rotor is cracked, or different type of problems you can identify if it is a electrical problem. Otherwise most of the problems are coming because of the bearings or bending of the rotor, or you can say misalignment or unbalance of the rotor of the electrical motor. So this way you can identify and isolate, and most of the problems can say isolated. And I will tell you what is the danger if you are not monitoring the vibration, or you are not monitoring, you can say through observing this LLF strategy. The problem is that most of the problems are electrical motor will transfer to your driven equipment. When your driven equipment gets damaged, then you have to stop the process and stop the equipment. So it is very necessary that this simple equipment electrical motor should be maintained in a proper way. And some high ST motors, when you are going to do the alignment, there is some what called it is a magnetic center. So all these things it should be taken the precautions that the distance between the shaft and what you call the distance between shaft ends, DVSC, between driving equipment and driven equipment. Here in this case motor or pump, for example, that should be totally, you can say, as per the protocol. Protocol means what distance should you keep between the shaft ends, and what tolerances you should have for the misalignment, for the alignment purpose. So depending upon the use of the equipment, if the driven equipment gets heated up, for example gearboxes or anything else, then you have to have some tolerances in the alignment. So this alignment is done keeping into the mind of protocol. And most of the times this driven equipment is kept without disturbing, and only the motor is shifted for the purpose of doing the alignment. So here the electrical motor is very, very important. Sometimes problems comes in the base frame. If you have a crack on the base frame, you will have a different type of problems. If you have, you can say, not proper shimming on the base frame, or the base frame is not plain, then you will also have a different type of problems in the electrical motor. So that's why that's why it is very important that whenever you go to the any equipment, you should check whether your motor is okay or not. Once his motor is okay and alignment is okay, balancing is okay, most of the problems will removed from your equipment. So that's all from my side, and if you want to know more about it, you can comment it, then we will elaborate about the electrical motor. Thank you very much. That's all from my side today. Thanks.